¿Quieres estar a la última en innovación? Visita www.centrodeinnovacionbbva.com.
Tenemos uno de los tecnologías con más futuro en Big Data, se llama Machine Learning. Muchos de vosotros estaréis familiarizados con la tecnología y todo lo que puede ofrecer. El ponente David Gerster, he's VP of Technology at BigML, and I think they are doing a great job at commoditizing machine learning for the wide audience and the business user. And the proof that they are on the right path is that not only the big guys like Amazon are also machine learning software as a service applications, is the fact that BigML have done a great job at making it easy for everybody at a business level user, the actual extraction of value from data. David was here with us in November. He joined us at Big Data Spain. I think that you will see by yourselves how he can manage to make it easy what is very complex.
Thank you.
So thank you very much, David.
Thanks very much. Can everyone hear me okay? Okay. While people are coming in, I'll just give a quick overview of what I'm talking about, why I'm here. As Ruben mentioned, I'm the VP of Data Science at BigML. We are trying to take data science and make it into just another type of business analysis. And so, you know, data science is one of these buzzwords that we've heard a lot about. It seems to have originated in Silicon Valley, where you have whole teams of quantitative PhDs who are mining large amounts of data to get insight into it, to understand the data. You know, you have companies like LinkedIn and Facebook, you know, hiring these entire quantitative teams. But what about everybody else? And how does everybody else actually apply data science to get insight into their data? And my argument is that you don't need a PhD, you don't need a team of specialists, you just need the right tools to help you actually do these types of advanced analysis and get insight into your data. And so what we have sort of been taught to call data science, that's actually just another type of analysis, and it's actually pretty easy. The concepts, anyway, are pretty easy. And that's really my main point today, is that we've sort of been told to think of data science as something that's, you know, difficult, requires specialists. My main point today is that the concepts are actually very, very simple. And I'll be giving some examples of actually using data science to get insight into data sets. So while we're waiting for people to come in, could I just get a show of hands? If you were to classify yourself as more business or more technical, who would say that they're more business in terms of their background, more of a business background? Okay. And who would say that they have more of a technical background? Okay, okay. So I'm glad I asked. I'm glad I asked. This presentation focuses more on the concepts. So there's not a lot of math. There's not a ton of technical detail. What I've tried to do is focus on the concepts and, you know, provide examples to help explain predictive modeling. So the part of data science that we call predictive modeling. That's going to be my main topic for today. And so there will be a Q&A afterwards. If you have detailed, sort of geeky questions, please feel free to ask. All right, we still have some people coming in. I'm just going to give it a couple more minutes. What else should I say while we're waiting for people to get settled? Thanks again for Ruben for having me here. This is my second talk in Madrid, actually. Is that loud enough? Okay. Whoop. Okay, that's much louder. Thank you. As I was saying, this is my second time talking in Madrid. Last time I got all sorts of amazing questions from the audience. So really looking forward to getting everyone's feedback at the end. Okay, I think we're ready to get started. So today I'm going to be talking about predictive modeling. What do we actually mean when we say predictive modeling? I'll be doing predictive modeling on an actual data set, and then we can have some Q&A at the end. So let me start with a really simple example. There's a very famous data set called the iris data set. It has measurements of 150 flowers, and there's 3 species of flower, as you can see here. And the goal is, if we know a flower's measurements, can we predict what its species is? And so the data looks like this. And on the vertical axis, you have the width of the petals. On the horizontal axis, you have the length. And there's 3 species with the 3 different colored dots here. That's species number 1, number 2, and number 3, right? And we're going to play a game. And the game is, we're trying to draw rectangles around these colored data points. And we're trying to do it in such a way that the rectangles are, they contain only one color of data point, right? So we're trying to draw rectangles around these data points such that we have rectangles that are all red, all green, and all blue. That's the game we're going to play. Now there's a catch, which is that the way we're playing the game, you have to draw lines that are perpendicular to the axes, right? So only horizontal lines, only vertical lines, which is another way of saying that you're drawing lines that are constant values of one of these axes. And so where would you draw the first line? Again, the goal is to get to draw rectangles that are purely of one color. And you have to draw one line at a time, and you have to draw it perpendicular to the axes. So where would you start if you were trying to do that? Well, you might start there. And in fact, if you feed this data to BigML, that's what BigML will do. And so now you can see we have a perfectly red rectangle over here. So we're done with that area. We don't need to draw any more lines because we've got a perfectly red rectangle. So we're going to focus on the other rectangle, which is green and blue. And so what line would you draw if you're trying to get the best separation between green and blue? Again, you can only draw lines that are perpendicular to the axes. Well, you probably draw that. And now you've created a rectangle that's perfectly blue. And so we don't have to look at that rectangle anymore. We're done. You can't do any better than 100% blue. Now, that leaves us with this rectangle in the middle. And here we have kind of a problem, right? Because there's no way to draw a line that gives you perfectly green or a perfectly blue rectangle. But we're going to do the best we can. And you end up with something that looks like that. We now have a rectangle on the left, which is almost perfectly green, but not quite. It has that one blue dot in it. And then we have the rectangle on the right, which is, mostly blue dots with a couple of green thrown in. And we're just going to stop there, right? We're going to say this is the best we can do given the data that we have. Well, congratulations. You just trained a predictive model. These rectangles are a predictive model. And the predictive model is these rectangles. It is literally correct to say that these rectangles are the model. And so that's our model. And what we're going to do with these rectangles is we're going to go out and we're going to find new flowers that we haven't seen before, that weren't part of this original data set that we used to draw the rectangles. Right? We looked at our historical data, we drew these rectangles, which are our model, and now we're going to go out and we're going to get totally new data points, new flowers. We're going to try to predict what species of flower it is based on these measurements. And so if we find a flower that has these measurements, short, thin petals, it falls in the red rectangle. So we're going to predict it is a red data point. We're going to predict it's Iris setosa. If we find a flower that has measurements in the middle, falls into the green rectangle, we're going to predict green, right? All we're doing is taking the data points, finding which rectangle they actually fall into. It's really very simple. We find another new flower that has long, fat petals. It falls into a blue rectangle. We predict that it's a blue data point, and so on and so forth. So congratulations. You just scored 4 new data points using the model. And all we did in this 2-step process was, number 1, we drew the rectangles, and number 2, we figured out for our new data which rectangle each data point falls into. And we make a prediction based on which rectangle the data point falls into. We predict green or red or blue. So I'm pretty much done. That's actually the main point of the whole talk. So if you guys have somewhere to be, please go ahead. This really is the main point, though. There's so much hype and so much complexity when people talk about predictive modeling. The concept is very simple. First, you draw your rectangles, then you figure out which rectangle your new data falls into, and you use the rectangles to make predictions on new data. And the key concept here is that we train the model using historical data, and we make our predictions using new data. And hopefully it's obvious that the model is only going to be as good as the data, right? The rectangles that you're drawing are only going to be good as the data points that you have to draw around. So that's the main concept. Again, I can't emphasize enough. The predictive model is the rectangles. The rectangles are the predictive model. So we have a compact way of representing these rectangles that we drew, this model that we created. And you start off with a circle at the top that represents 100% of our data. And when we draw these lines, so we drew our first line there, that splits the data into two subgroups. Now, we're done with that subgroup. We're going to color it red. And we're going to split this one into two groups. We're done with that group. We're going to color it blue. And we split this into two groups, and so on and so forth. So this is a compact representation of the rectangles that we drew. And you can see it looks like a tree. We call it a decision tree. And in fact, the algorithm that I've been using is called a decision tree algorithm. And the final rectangles are called the leaf nodes. So it's a tree, it has leaves, very cute. One important concept is that you don't need to go all the way down to find interesting insights in your data. So here we are, and this is actually before we've drawn this line here. You can actually see in this middle rectangle here that there's a lot of green data points, a very high concentration of green data points. And you can see that even before we've drawn this final line. And so this is a very important concept. You don't need to go all the way down to the bottom of the tree to find interesting patterns in the data, right? In this case, this is not the final leaf node, but we still see the interesting pattern of having a high concentration of green data points. So you don't need to go all the way down to the bottom of the tree to find interesting insights in your data. All right. By the way, you can try out this data set at BigML. If you set up a free account, we give you the Iris data set as a housewarming gift. You're welcome. OK, so for my demo, I'm going to be doing an analysis of a sociological survey that's given in the United States every couple of years. And the survey is 400 questions. There's almost 40,000 responses. The questions are about anything you can imagine about someone's private life, their political views, their demographics, their finances, you name it. And you can almost think of this as marketing data, right? In fact, you can think of this as a subset of what Facebook knows about you, right? And so we're going to be taking these survey results, and the question is, given all this information I have about you, the answers to these 400 questions in this survey, can I predict your income, whether your income is above or below the median income for the United States? And so I've already taken the step of loading this data into BigML. And you can see it just goes on and on and on and on. And this is just the first page. And this is just the first 100 questions. There's 400 questions. And it really is anything you can imagine. For example, how good is your understanding of political issues? And you answer the question, quite a bit, some, etc. So this is really giving a very detailed look, not as detailed as Facebook, but still a very detailed look at a person's psychographic profile, if you will. And I'm going to try to predict whether someone's income is above or below the median. So I'm going to configure a model. And again, by a model, I just mean we're drawing these rectangles, right? In this case, we're going to be drawing the rectangles to get rectangles that are purely low income or purely high income. And we're doing it, in 400 dimensions instead of 2, but it's really the same thing. I'm going to tell BigML to only draw a total of 50 leaf nodes, 50 rectangles, just so it's easy to read. And I'm going to click Create Model. So this is all happening in the cloud. BigML is a cloud-based machine learning service. The algorithm is drawing these rectangles, and we get this tree. And this data at the top represents 100% of the people who responded to the survey. And you can see it's split about 50-50 between high and low income. And the first line, so remember that game that we played, right? The first line that BigML draws is whether you're married or not. So the subset of people who are married, 2/3 of them have income above the median. The subset of people who are not married, 2/3 of them have income below the median. So that's a very interesting finding just by itself. And then it keeps drawing the rectangles, right? We go over here to the married people. If you have completed high school, then it's much more likely income. If you haven't completed high school, it's much less likely. And what we're going for in each of these dots, right? These dots each represent, again, a rectangle. That's a subset of the data, right? What we're looking for, ideally, is all of one bar and none of the other, right? We want perfect separation between the two groups. And you can see, we start off with 50-50, and here we've got, the subgroup of people that are married, 2/3 of them have high income. The subgroup of the married people who completed high school, 80% of them have high income. Keep on going. If you are married, completed high school, and you're older than 28 years old, then you're almost 85% of those people have high income. And so you start to see how BigML is intelligently drawing these rectangles, trying to get purely one class or the other, right? We're trying to get rectangles that are all high income or all low income. You can go over to the other side here. So if you're not married, if you're not working full time, and you didn't make it past the 10th grade, then more than 93% of the people that fit that description have low income, which is not a huge surprise. And so you start to see how you can really get insight into your data using this technique. You're able to find these really interesting patterns. And when you see these patterns, does that make sense? It all makes pretty intuitive sense. You'll notice that I have to mouse around to find the interesting patterns. Well, there's an easier way to do that. We call it the sunburst view. So this is the same decision tree, except this circle represents 100% of the data. And the subdivisions are represented by these arcs. And you can see that these arcs split into two, and then split into two again. It's the same structure as a decision tree, except here we've represented it. And the cool thing about doing it this way is you can color these arcs. In this case, we've colored it with bright green for better separation between high and low. And so you can just look at this, and you can say, oh, well, there's some bright. That looks like an interesting pattern. And you just mouse over it, and it tells you, OK, here's a subgroup. Running out of screen space here. Here's a subgroup of people that are married, they are working full time, they completed high school, they're older than 28 years old. 90% of those people are going to have high income. And by the way, these are not, this is not theoretical. This is an actual pattern in the data, right? the model is telling us that the subgroup of people that meets these 4 criteria, it is a fact that 4,600 of them are high income and only 512 are low income. And 4,600 over 5,100 is roughly 89%, right? So this is not some abstract calculation. This is a real pattern in your actual data. And BigML is telling you what that pattern is. And so, again, the great thing about this visualization, as opposed to the decision tree, is you can just look at it and see where the interesting patterns are. The interesting patterns are where you see the most bright green. Again, over here, you see a group that is almost 94% low income, and that stands out as bright green. In fact, you don't even need to know anything about the model, right? You can just look at it, and you can see, okay, there's some bright green over there. What's that all about? And so it's a very powerful visual tool for business, right? It makes it really easy to see where the interesting patterns are in your data. All right. So that was the sunburst. Now, it's great that we're getting all this insight into our data, right? It's great that we're able to see all these interesting patterns. But how do we quantify whether the model is good or not? So we have some sense that it has a lot of bright green and that that's good. But how do we quantify that? The answer is we hold out some of our data when we train our model. So in this example, I'm holding out 20% of the data. I'm going to train my model on the other 80%. And again, when I say train my model, I simply mean draw my rectangles, right? But instead of drawing the rectangles on 100% of the data, I'm going to draw them on just this 80%. I'm going to hold out this 20%. And I'm basically hiding that from the model, right? The way I'm doing this, the model doesn't know anything about what's over here. Now, we actually know whether this hidden 20%, we know if it's high or low income, or we know if, what species of flower it is, right? We actually know the answer for what we're trying to predict. And so the trick is you feed these data points to the model. You score these data points. Remember the first slide. So here we have a red data point, and we feed it into the model, and we say, hey, it's in a red rectangle. That's good, right? That means the data is making the correct prediction for this data point. Then we do the same thing for this green data point. It falls into the green rectangle. That's good. The model made another correct prediction. Take this blue data point, blue rectangle, good. But this green data point falls into a blue rectangle, and that's bad. This means that even though the actual data point is green, the model is predicting that it's blue, and that's incorrect. And so in this case, we would say that the accuracy of the model using this holdout set is 75%. Now, obviously, we're going to use more than 4 data points in real life, but you get the idea. We're checking our model by holding out some of the data and then feeding that data to the model. And from the point of view of the model, it's brand new data, right? It wasn't used to draw the rectangles. It wasn't used to train the model. And so this is a good way to check the accuracy of your model offline before you use it to make predictions. And this is a very common technique. So I'm actually going to do this using BigML. I'm I'm going to go back to my data set, and I'm going to split it into 80 and 20% groups. And BigML is going to bring up the 80% data set, and then I'm going to train a model on it just like before, only now we have this hidden data, this 20%, that we're going to use to check the accuracy of our model. And so this is the 80% data set. I'm going to create my model. Again, I'm predicting income. And so just like before, we're training a model. You'll see it finds very similar patterns on the 80% data set as it did on the 100. At least it should. This is all live, so you never know. So you can see it's making the same distinction between married and unmarried people and so forth. So now I'm going to evaluate the model. I'm going to take this 20% that was held out. I'm going to feed that to the model. I'm going to see which rectangle each of those data points falls into, check if the model is making the right prediction for these new data points. And you can see the model's close to 74% accurate. And that's pretty good, because from just random guessing, you would expect about 50% accuracy. So that gives us some level of confidence that our model is making good predictions. So, all right, that's pretty interesting. But you know, predicting income is not really controversial enough. So let's see if I can do something more interesting with all of this really juicy data. What if I tried to predict people's political views using this data? That sounds pretty controversial to me. So I'm going to go back to my data set. And there's actually a field in here that is whether you are a liberal or a conservative. And so of our responses, you can see it's roughly evenly split between conservative, liberal, and moderate. Now I'm interested in figuring out what are the differences between conservatives and liberals. So I'm going to get rid of the moderates, and then I'm going to train my model. And that's going to tell me what are the differences between conservatives and liberals, and forget about the moderates. So I'm going to configure my model. And instead of trying to predict income, I'm going to try to predict if you are liberal or conservative. Oh, actually, sorry. I'm going to go back to my data set. First, I need to weed out the moderates. So I'm going to filter my data set. And I'm going to say, let's filter out the moderates, because that's boring. Liberal. There we go. So I'm going to say filter out the moderates. And I'm also going to get rid of a couple of fields that I would expect to strongly overlap with whether you're liberal or conservative. So I'm going to get rid of political party. Right? It's not very helpful to say that if you're a Republican, I predict that you're conservative. It doesn't really tell me very much. So I'm going to get rid of political party. So I'm going to create this new data set. And then I'm going to train a model on this data, except instead of predicting income, I'm going to try to predict your political views, whether you're conservative or liberal, but not if you're moderate, because that's boring. And so I'm going to change the thing that I'm trying to predict. So before I was trying to predict income, now I'm trying to predict if you are liberal or conservative. And I'm going to limit the model to 50 rectangles, just so it's easy to read. And I'm also going to turn on this thing called missing splits. A useful feature for survey data, because it treats a missing value as a response. It treats the respond as a response. And that can actually be very useful when you're dealing with survey data. It can actually tell you a lot when someone chooses not to respond to a question. And we'll see that in a minute. Create model. So again, we're drawing the rectangles, trying to find data points that are more purely, trying to find rectangles that are more purely conservative or liberal. And here we go. Now, let me preface this by saying that this is what the model is finding. This is not about my own personal political views. And that's what's really interesting about this. The model is finding some very specific patterns about what makes you liberal or conservative in the United States. Just keep in mind, this is just a pattern in the data, right? This is not something that I was specifically looking for. Okay. This dot at the top represents 100% of the data. It's roughly 50-50. The data set is a little bit more conservative than liberal. And the first line that the model draws is based on the respondent's opinion on homosexuality. And so 5 means you strongly disapprove. 1 means you don't disapprove at all. And so if you don't disapprove of gay rights, basically, if you're against the death penalty, and if you think, if you're pro-choice, basically, then 85% of those people that fit that description for those 3 things, 85% of the time, you're liberal. 3 things, right? Keep in mind, the model doesn't know anything about American politics, doesn't know anything about religion, right? It's just finding these patterns in the data. And again, this is an act, right? This is not some calculation. It is a literal fact that the people that meet these 3 criteria, within that group, 1,100 of them are liberal out of 1,300. And that's roughly 85% of that group is liberal. Now over here on the other side, we have a group that skews more conservative. You'll notice that this says your opinion on gay rights is more than 2, which means you disapprove, basically. 3, 4, or 5 means you sort of disapprove or really disapprove. And it also says if it's more than 2 or you didn't respond, right? And an interesting thing to note about this survey is that it's actually administered face-to-face, right? And so, do you disapprove of gay rights? If you actually feel that way, you may not want to express that sentiment face-to-face with somebody, right? And so it's very interesting that the missing responses tend to skew conservative, right? My interpretation of this is that there were some people who actually do disapprove of gay rights and just didn't say a pattern. Now within this group, if you disapprove of sex before marriage, that group is even more conservative. And again, if you didn't say anything, right, if you didn't respond to the question, that also puts you, tends to put you in the conservative category, right? And again, it's very interesting that you see people holding back on their real opinion And it just keeps going. If, in addition to those two things, you also are white, and if you go to church almost every week, and if you live in a single-family detached house, which basically means you live in the suburbs, if you meet these 5 criteria, then almost 86% of the time you're conservative, right? And you start to see the sort of patterns that we can find in the data set. So imagine that this is, again, a marketing data set. Again, this is a subset of what Facebook knows about you, right? So, you know, imagine that you are at Facebook in marketing, you're trying to predict someone's political views. This is giving you really nuanced insight into people's behavior, right? It's finding these very detailed patterns. If you go one more level down, it finds another pattern, which is if you're Protestant, but not United Methodist, then you're even more likely to be conservative. So in addition to those 5 things, you add the 6th thing, which is that you're Protestant, but not United Methodist, then it's even more likely that you're conservative. And I saw that, and I thought that was strange. I thought the model might be just sort of finding random noise. It turns out that the United Methodist Church is actually having a big internal fight on the topic of gay marriage. And in fact, there's a very large liberal wing within the United Methodist Church that is in favor of gay marriage. And so the model is actually that pattern in the data, which I think is pretty amazing when you think about the level of detail there, right? The model is finding out that if you're Protestant, not United Methodist, then you're more likely to be conservative. And so this is really a great example of just the rich detail and the rich insight that you can get into your user behavioral data using predictive modeling. By the way, another great thing about predictive modeling is that you can get a summary of the variable importance. And in this case, out of the 400 variables, right, we've identified 10 here that are the most important in predicting your political views, leaving out the moderates, right? Keep in mind we left out the moderates. Number 1, far and away, is your opinion on gay rights, followed by your opinion on sex. Next is your race. Next is your philosophy of how how the federal government should redistribute income. That's number 4, right? The first 3 things, I would argue, are not even really relevant to policy. We get to number 4, we find, you know, people's opinions on policy, your stance on the death penalty, whether you go to church, and so forth. Interestingly enough, 4 of the top 10 are religious, right? These 2, and how often you go to church, and what type of Protestant you are if you're Protestant. This is very useful because it's telling you, here's the small subset of variables we want to focus on out of 400, right? By drawing these rectangles, by training this model, we figured out what actually matters to predict the thing we're interested in. And again, 4 of the top 10 variables are actually based on religion. And why is that? Well, it turns out that in general, wealthier nations tend to be less religious. You may have seen a version of this chart before. Here are the wealthier countries, including Western Europe, and there's the United States. And you can see the United States is an outlier among wealthy countries in terms of its religiousness. And so it's not so surprising that 4 of the top 10 things that predict whether you're liberal or conservative would be related to religion. By the way, the other big outlier is China, but that's a whole different presentation. Okay. Hopefully I've given you a feel for how predictive modeling can help you get this rich insight into your data, how it can help you isolate the subset of variables that actually matters for what you're interested in predicting, which could be customer lifetime value. It could be something like churn. It could be whether a transaction is likely to be fraudulent or not, right? It's really a question of what are you interested in predicting. Then the model will actually tell you, hey, these are the important variables for making those predictions. My final thought is that data science is easy, right? Hopefully I've demonstrated that the concepts here are not really that hard. We're just drawing these rectangles. Now, if you have a PhD in something, you call what we just did data science. I just call it data analysis. Just don't tell that to the White House. Thank you very much. Do we have time for some quick Q&A? Do we have time for some quick Q&A?
1 minute on maybe one question. David, I have a question for you.
Yes.
So how do you see a difference between startups and large enterprise adopting easy software as a service machine learning solutions?
I think that what we're seeing is that the companies that are most interested in something like this actually tends to be large companies that have a lot of data to analyze, but they don't necessarily have a data science team in place. Or if they do have a data, it's really hard to get their time. And so, we have a company that's using us to predict whether a hard drive return is fraudulent or not. So when a drive breaks, you want to immediately ship one in the mail so the user is happy. And sometimes people will take advantage of that and send you a brick in the mail. Meantime, you've sent them the real hard drive. And so, that's an example of a multi-billion-dollar company that's using the ML as a service approach to get this insight into their data without having to have a team of PhDs working on the problem.
Fantastic. Thank you very much.
Thank you very much. Did we have time for one question from the audience? Let's get one question from the audience. No? Someone? Yes.
Do you implement any other algorithms apart from trees?
So we've implemented decision trees in random forests for predictive modeling. So you can have any algorithm you want as long as it's a decision tree. We also do anomaly detection and clustering, which I did not demonstrate. We deliberately chose the algorithm to make the workflow really easily. Yeah. Great question. All right.
Fantastic.
Thank you very much.
Si quieres estar a la última en innovación y emprendimiento, visita www.centrodeinnovacionbbva.com.